All right, Mr. Ahmed here, starting up chapter 5. We are going to be working with triangles for this entire unit. It's a pretty long one. We're going to break it apart into 2 quizzes. Our first quiz will be over section 5.1 to section 5.4. So, my recommendation is for this note pack, you definitely are going to want to have it. There's a lot of information in this chapter. So if you can't print it, they are located outside door 1 in the bin, so make your way that way to pick one up. Goal for 5.1 is just the intro to triangles, and the first thing we need to do is just define what a triangle is. So our essential question really for today is, what is a triangle? And some of its features. So we're just going to go over some basic things. First step, what is a triangle? A triangle is a polygon with 3 sides. So that means all 3 sides are straight, okay? So polygons have straight edges, and we are going to work with 3-sided figures when we're talking about triangles. This first part you probably have seen before, and that is classifying triangles. Now, as you are working on the assignment, make sure you read if it says to classify it by its sides, or if you classify it by the angles. The first way is classifying by the sides. So when we classify a triangle by its sides, if it has no congruent sides, that means all 3 sides are different lengths, it is scalene. So a scalene triangle, none of the sides are the same length. An isosceles triangle has at least 2 congruent sides. So keep in mind our tick marks. Those show congruence. So if you see a tick mark on 2 sides, that means they are the same length. This could be like a 7 and a 7. And finally, an equilateral triangle has 3 congruent sides. So all 3 sides are the same length. For example, they would be an 8, an 8, and an 8. Okay, so that is an equilateral triangle. One thing with the equilateral triangle is it is also considered to be isosceles because it also does have 2 congruent sides. However, when you need to classify it, make sure you classify it by the most specific name. So if it has 3 congruent sides, yes, it is isosceles, but we want to call it an equilateral triangle. When we start working on some of the properties, the main reason why we use that is because the equilateral triangle also has the same characteristics as the isosceles triangle. When we classify by angles, classifying by the triangle's angles, we are going to look at the interior angles, which are the angles inside, the ones you've always worked with. If the triangle has 3 acute angles, it is considered to be acute. So that means all the angles are less than 90. Okay, so 3 acute angles. Less than 90, less than 90, less than 90. A triangle is a right triangle if it has exactly 1 right angle. An obtuse triangle has 1 obtuse angle. So one of the angles is bigger than 90. And an equiangular triangle has 3 congruent angles. So in this case, it's marked with the tick marks on all 3 angles. That means those are the same size. The next thing we need to discuss after we're done with our classifications is an interior angle versus an exterior angle. Typically, all the angles you've worked with in the past are interior angles. And the interior angles are on the inside of the triangle. So Z, X, and Y, those are all interior angles. They're on the inside. Okay, so I'm going to highlight those in green. So interior angles are on the inside. Z, X, Y. The exterior angles form a linear pair with the interior angle. So in this diagram, our lone exterior angle is angle W. It's outside of the triangle, and it forms a linear pair with the interior angle. Now, technically, I could draw this side here, and this angle would be an exterior angle as well. And I could also extend this side, and this angle would be an exterior angle. All right, so those are the exterior ones, the ones on the outside. Forms a linear pair with the interior angle. So that means these two have to add up to 180 degrees. So those are kind of the basic key things with the angles. The next piece is the triangle sum theorem. You might have seen this before, but the sum of the measures of the interior angles of any triangle always adds up to 180 degrees. So angle A on the inside, B and C, those always add up to 180. So a lot of times we're going to have to find a missing angle. When you find a missing angle, we're going to set up an equation because all the angles of the triangle have to add up to 180. So I would say that 180 is equal to first angle 27 plus 98 plus the missing one, x. And then we can solve for x to find the missing one. Now I do understand that you could just take 180 minus 98 minus 27 because you know they add up to 180 to find this, but I wrote out the equation because some of these are going to be a little bit trickier, like there might be a plus x or a 2x, and we'll have to actually solve the equation. So that's why I wrote it out this way. So we're going to solve it. 27 plus 98 is 125. And then we'll subtract our 125, and we get 55. So we have found the missing angle. It is 55 degrees. The exterior angle theorem, this one, super imperative. All right, you'll forget it. We'll use it this first unit, and then we'll kind of forget about it. But it is very useful. We have to keep it in mind. When you see an exterior angle, you have to think back exterior angle theorem, exterior angle theorem. All right, we're going to have to use it a ton. So what it states is the measure of an exterior angle of a triangle. So in this case, the exterior angle is angle 1. This is the one on the outside. Is equal to the sum of the measures of the two non-adjacent interior angles. So the two non-adjacent ones are the ones that it's not right next to. It's right next to angle C. It is not next to angle A and B. So the ones across from it. So angle B plus angle A, those two added together is equal to the exterior angle. All right, so we'll have to take the measure of B plus the measure of A. That's equal to the one on the outside. So the one that it's not right next to. If you see an angle on the outside of the triangle, this is probably what you are going to have to use. Okay? So, example here. Find the measure of angle DCB. First thing I want to do is identify DCB. DCB, that's this one here on the outside. So, since it's on the outside, I'm thinking exterior angle theorem. The exterior angle, 3x minus 9, is equal to the sum of the two that it's not right next to. So it's right next to this one, so it's equal to 73 plus x. And then we'll solve the equation. So I am going to subtract x from both sides. 2x minus 9 equals 73. Add our 9. Get 82. And then when we divide, x is equal to 41. So I found x. The question, however, said to find DCB, so I have to plug x back in. Okay, we're going to have to plug it back in to figure out what the angle is. So the measure of angle DCB is equal to 3 times 41 minus 9. And then we'll just calculate that out. I used a calculator and got 114 is equal to the measure of angle DCB. And that is in degrees. So make sure you read the question. You might have to find x. You might have to plug it back in. All right, so a couple more challenging ones here. This one says find the measure of angle 1. So in this diagram, a couple key things. I see a big triangle, a little triangle to the left, and a little triangle to the right. When I see triangles, the things I know, the angles add up to 180. So if I'm looking at angle 1, I'm thinking angle 1 is equal to 52 plus 2x plus whatever it is. That's another variable. So I can't just say these three add up to 180 and figure it out because I have too many missing things. So, all right, well, here's this angle. If I cross off this triangle, this angle is on the outside. So it is an exterior angle of this triangle on the right. So I'm going to use the exterior angle theorem. 3x plus 16, the angle on the outside, is equal to the two that it's not right next to added together. So that's 52 plus 2x. And then I can solve for x. So when I solve for x, subtract 2x, x plus 16 equals 52. 52 minus 16 is 36. So x is equal to 36. So now that I know what x is, I have some options. I could plug it into this one, and these three angles add up to 180, or I could plug it into this one, and these two add up to 180. I'm going to plug it in here. So when I plug it in, 36 times 2 is 72. So I know that this angle here is 72 degrees. So for me to find angle 1, the measure of angle 1 is equal to, let's just take 180 minus 72 minus 52. Or you could have wrote out an equation and said angle 1 plus 2x plus 52 equals 180. Option's yours. So I'm just going to subtract on this one. So 180 minus 72 minus 52 is 56. So the measure of angle 1 is equal to 56 degrees. We got it. All right, hit pause and give the next two questions a shot. They're both a little bit simpler than this one. This one's a bit tougher. So just give those two a try. Then you can unpause it and check to see if you got them right. All right, hopefully you had some success. So the first one, these three angles are on the inside. So I'm going to say that 2x plus 3x plus 4x adds up to our 180 degrees. Because that's the whole triangle. 2 plus 4 is 6. 7, 8, 9x equals 180. 180 divided by 9 is 20. So x is equal to 20. We got it. All right, now the next one, this angle y is on the outside. So we're probably going to have to use exterior angle theorem. Angle on the outside is equal to the two that it's not right next to added together. So 70 plus 88. And 70 plus 88 is 158 degrees. So we found y. All right, that's it for today. Have a good one.